Hi, this is a series of the videos I'm going to upload into our chemistry class website. And the beginning with the today's one, I'm going to discuss the October 23 Unit 1, Section A in this video. So you can see how the questions and the answers are done as it is the progression of this paper. So the Section A, the very first question, they meet up in this very first question is the subatomic particles present in this aluminium. Aluminium is given to you 13, 27, 3 positive iron. So the idea is to find the correct number of subatomic particles. Whenever there is a question, it's easier to find the subatomic particles by yourself. So it is 13 equals to number of protons 13. Electrons should be equals to 13. As it is 3 positive, it's lost 3 electrons. So it is 10 would be the number of electrons. So the number of neutrons would be equals to 27 minus 13. Mass number minus the atomic number. So you get the answer 14. So the answers which tally with this 13 protons as well as this 10 electrons and the correct answer with 14 neutrons, it comes the answer T. First question answer is T. Second question is based on this shape of the p orbitals and number of electrons. In this question, the hint is given to you is a p orbital. Second question, a p orbital. So it is the hint given to you. A means one p orbital. So it is usually double in shape. Your answers A and the B are out. So your choice should be out of C or D because this p orbital is a dumbbell in shape. So in that shape, it gives you the number of electrons carried would be 2 electrons. So the 2 electrons is carried with the answer should be best answer is the second question is C. Moving on to the third question, it's based on calcium carbide. Third question is based on calcium carbide. You are given the formula of the calcium carbide and asking the formula of the carbide anion. In the third question, carbide anion, the formula. So it's easier to get as it is calcium being in the group 2. It is having 2 positive charge. So obviously carbide should be 2 negative. So the best answer for third question is C with the carbide ion which is having this formula C2 with 2 negative because calcium 2 positive to be neutralized it needs 2 electrons with the anion. And the third question A is this part and there is another part with continuation in third question B part. So in the B part, it gives you an equation, calcium carbide react with 2 water. It produces ethane, at the same time calcium hydroxide. This balance equation is provided to you. Your question is, find this is the mass of ethane that form. Obviously, mass of ethane. So whenever there is a question like that, put a question mark. Mass of ethane is asking. The given thing is 10 grams of water but excess calcium carbide. We are not interested as it is given to you excess calcium carbide. Our relationship should be with the water and ethane. Asking thing is ethane. Find the MR of ethane. So 2 carbon, 2 hydrogen. So it is 2 times 12 plus 2 times 1. It comes 24 plus 2. 26 is the molar mass of this ethane. 26 is the molar mass. And the water we know it is this, the 2 hydrogen, 1 oxygen. 2 plus 16, the molar mass is 18. So it is the MR is 18. Our connection, our relationship should be between these two. So we should write down, having known these two MR values, you're asking the mass of ethine. If you use 2 times 18 grams of water, you should end up with 1 ethine, which is 26 grams of ethine. So this is the very clear format. If you write what's the answer should come to your right hand side clearly. 1 gram of water gives you 26 divided by 36, which is 2 times 18 is 36 grams of ethine. So your question is for 10 grams of water. So it should give you 26 divided by 36 times 10 grams of ethine. If you simplify the answer, 7.22 gram, which gives you the B part as the answer. B part of the third question to give you the answer as the A answer. It's very easy to do the calculation if you understand what is asking very clearly and keeping that quantity to your right hand side. This is the end of third question. We are moving to the fourth question, which is based on electron density maps. In the electron density maps here, so it is based on sodium fluoride. The fourth question, sodium fluoride. So there are electron density maps. So first you should work it out. Sodium is a metal, fluoride is a non-metal. They have their opposite charges. Usually the positive ion is smaller in size, negative ion is the bigger in size. So obviously there should be smaller as well as the bigger areas. And there are no lines connecting that. So it's choosing the best answer for fourth question is the A, because C and the D are obviously not correct because there's a common region in C and the D answers. It shows covalent bonding. And the B is wrong because in your answer B it is equal size of electron clouds are present. So obviously sodium 1 positive is smaller than the chloride. So the best answer is the A for this question 4. We are moving into question number 5. It gives you a compound in this question number 5. It is the ammonium chloride. Compound given to you is the ammonium chloride. You are asking what type of bonds are present. When you are given the structure, you can just get to know ammonia is having this kind of molecule with a lone pair. It is donated to the lone pair through the dative covalent bond, and Cl minus ions are there to attract together. So obviously, this is a dative covalent bond, and all these the other bonds are just covalent bond. So it is having covalent, dative covalent, and after that they attract to us with each other with ionic bonding. All these three types of bonds are present. So the question number 5, the best answer is the D. Question number 6, it comes with this electronic configuration of 4 different elements. Question number 6. So it gives you A, B, C, D, 4 elements, and the A is the electronic configuration, which is coming as this 3s2, 1s2, 2s2, 2p6, and 3s2. So when you count all these numbers 2 and 2, 4 and 6, 10 and 2, 12, obviously it should be magnesium. Same with the B, it comes here 3s2 and 3p1, it should be aluminium. And the B, it should be the aluminium. C, it gives you 3p2, and the D, it is the last one is 3p3, which gives you very clearly magnesium, aluminium, because 3s2, 3p2, 3s2, and 3p3. So this should be silicon and phosphorus. When you get to identify, once you identify it, it is very easier to put into our normal pattern. Sodium, magnesium, aluminium, silicon, phosphorus. Sodium is not given in the aluminium, silicon, phosphorus. What you should see here is this kind of relationship we can obtain. Sodium, magnesium, aluminium, silicon, phosphorus. Our variation of first ionization energy slightly decrease aluminium, silicon and the phosphorus. This is the pattern that we are aware. So out of the given four elements, you are asking the given four elements, magnesium, aluminium, silicon, phosphorus. They are asking the answer with bold word, lowest. Lowest should be the aluminium. So the best answer should be the B. Question number 6, the answer should be B. Question number 7, it provided a U-tube. So it is that question number 7 we can move on to. U-tube is being provided in a diagram where a compound is being filled inside this copper to chromate. This is an evidence. Question number 7 is an evidence how the ions are moving during this ionic compound is electrolyzed. So it is not this electrolyte, but it is two electrodes are inserted and this is connected with this kind of power supply. By looking this diagram, you know, copper to chromate is filled inside here. Copper CrO4 copper chromate solid. So O copper chromate aqueous solution should be there. Then it is this negative electrode here become negative, positive sign make this positive. The diagram is not mentioned that, but it is written in the words positive. So obviously, copper chromate is made up of these two types of ions, copper ions and the chromate ion. So the copper ion is blue in color, chromate is yellow in color. Obviously, copper chromate should be green because it is the blue and the yellow combination gives the green color. Your question based on which color should be seen at each of the electrode. As this is a negatively charged, positive copper ion comes around a lot, making this area blue. As this is positive, negative chromate ions comes around, making this area yellow. So once you see the answers, so the best spelling answer should be the C, because it is the blue towards the negative electrode as well as the yellow towards the positive electrode. So the answer for the 7th one should be C. We are moving on to the question number 8, which is the part of the mass spectrum is provided. In this part of the mass spectrum, your question is, you can see it is the part of the mass spectrum only. But they are asking which region in which the particles are ionized. Obviously, where there is an electron gun is placed, fast moving electrons are now towards the sample is sending, is you can recognize which is the Q. So obviously the answer Q, the equation, the answer B, where the region where the particles are ionized. Question number 9 that also relates into the mass spectrum. So it gives you sample of chlorine was analyzed in the mass spectrometer. It is made up of two chlorine types of atoms, 35, 37 isotopes. And the question is total number of peaks. Total number of peaks due to the ions. So obviously the total number of peaks comes with the atoms of this chlorine as well as the molecules. So it can be produced fluorine 35 with 1 positive charge. Mass over charge should be 35 over 1. Also could be chlorine 37 with 1 positive charge. 37 over 1 is the mass over charge. So if we get in these two are the elements of chlorine. At the same time, it is possible chlorine molecules of 35 with the mass over charge 70 over 1, which is 70. Also chlorine with 37 with this positively charged single charge 72 over 1 together with 237 of chlorine atoms with positive charge of 74 over 1, which makes 72 and the 74 altogether 5 peaks. So your answer for this question number 9 should be the best answer is the C, which gives you the idea that's the question number 9. It is the best answer is the C, which gives you 5 peaks altogether producing this fluorine. We move on to the question number 10 regarding this the electrophilic addition reaction of propane with hydrogen fluoride. Propane is an unsymmetrical alkane. Your question number 10 based on propane. And this says it is this. Propane comes here. It is the H and the double bond with the carbon and the H and the H together with the carbon with 2 hydrogen with 1 hydrogen. Altogether, this is the structure. When it is added the hydrogen fluoride, so hydrogen fluoride anyway is a polar molecule. So this the electrophilic end comes here, this H plus. As it is approaching, this gives this charge separation. So this molecule, as it is unsymmetrical, it can give rise to 2 different products, which is leading into hydrogen goes to this carbon. If the hydrogen comes into this carbon, then there is the positive charge on the other carbon. So there would be hydrogen here, hydrogen and the hydrogen. This is that one of the possibility with this kind of situation, or else it could be hydrogen could be attached to, if this is the possibility, or this the other possibility, there would be the carbon with corner carbon get the positive charge. Hydrogen is attached to, this is this hydrogen attached to this hydrogen, and this is 3 hydrogen already at the corner, so it could be normal hydrogen, and this is the positive charge on the middle one with 1 hydrogen being attached to. Either this possibility, or it can be here the corner carbon get this positive charge where the hydrogen can be attached to middle of that, where all the other carbons are having hydrogen which were having at the beginning. So the corner carbon is having now, it is the 2 hydrogen and the positive charge. This is the condition with this unsymmetrical alkane. It is attached to the hydrogen fluoride. Hydrogen can be moved away either to corner carbon or middle carbon. So it can be here as well as here. It gives you 2 different intermediates, intermediate A and the intermediate B. Question says most likely to occur, no choice, it is the middle carbon to get the positive charge, because that with inductive effect this is more stable. So it is your best answer is the 10th question is the C part, which is the most likely to occur. Your 10th question A part, the answer C. 10th question B part, there is a part where the reaction is known as, definitely is the D answer, it's the electrophilic addition reaction. It added across the double bond through an electrophilic part of the hydrogen. So obviously the structure is, this is the most stable, but there is another chance of having less yield can be created, higher yield, greater percentage of this intermediate and the particular compound. Fluorine comes here. Here can be the fluorine to the corner. So the electrophilic addition reaction, this is the answer. And we are moving on to the 11th question. It is again some kind of statement made regarding this alkene. Question number 11. Ethene reacts with potassium permanganate with an acid to make this the 4 statements made by a student. So whenever you are getting this type of question, best thing is to write down this product. So in that condition, when ethene is reacted with potassium permanganate, it gets oxidized, oxidation take place. So each carbon of the double bond get OH. At the same time, it is attached to the other hydrogens which were having at the beginning, including it should be 2 hydrogen. So it should be the hydrogens that were attached to it at the beginning. OH comes here. Now we see the statements. Your question is the organic product can show geometric isomerism. Definitely wrong because it is not having the carbon-carbon double bond. And in the second one it says type of reaction take place. It's oxidation, yes. So the statement 2 is correct. It is the oxidation reaction. Third statement, bond angles around the carbon atom in the product. It is kind of greater than. This is 109.5 tetrahedral. At the beginning, 120 trigonal planar. So this third statement is not correct. Fourth statement says the acidified potassium permanganate decolorizes. Yes. So the number of statements correct are 2. So the answer should be B. 11th question, the answer is B. So we move on to this question number 12, which is based on the calculation, and it gives you the carbon dioxide concentration in a sample. It is 2.19%. So your question is, samples of a gaseous mixture contain carbon dioxide by mass. So it says by mass 2.19%. And your question is, what's the concentration in parts per million? So obviously 100 parts contain 2.19 parts of carbon dioxide. Baby grams, 100 grams contain 2.19 grams. So then it should be 1 gram. 1 gram the mixture contains 2.19 divided by 100 grams of carbon dioxide. The question is asking for, it's expressed in 1 million, 10 to the power 6 grams. So 2.19 divided by 100 multiplied by 10 to the power 6. So you get the answer for this one, 2.19 into 10 to the power 4 grams. So this best answer should be given for 12th A part is the B. This is 12th A part, answer is the B. 12th A part is the answer is B. This is the B answer, 12th A. Answer should be B. The 12th B part, solution of lead nitrate has concentration of 15 ppm, 15 parts per million. 12th B part, it says, there is a solution of lead nitrate, 15 parts per million. That's its concentration. You are asking what mass is present in 400 grams. That means it is, you are getting 1 million grams. It contains 15 grams. 1 gram 15 divided by 1 million. Therefore, in 400 grams. 15 divided by 1 million multiplied by 400. Once you simplify, it gets the answer as 6 into 10 to the power minus 3 gram, which comes your answer as A. 12th B part, answer is the A. 12th B part, the answer is A. We move on to the 13th question. You're asking to find which solution. In 13th question, which solution? You're provided 4 solutions. Out of that, you're asking to find which solution contain concentration of calcium chloride, which is that contain chloride ions. Your question is the 13th. Chloride ions, you provide calcium chloride in 2 answers and the sodium chloride in the other 2 answers. So it is A, B and the C, D. For solution, which solution contain 0.05 mole per decimeter cube of chloride ion? So to begin with this one, in your first 2 answers, 1.39 grams are given. And the second 2 is the same substance, 1.46 grams. And you can get the molar mass for all these calcium chloride and the sodium chloride. Once you get the molar mass, it is this 111 mR is for this and the 55.8 for sodium chloride. To show the answer, I'll show you A part. The answer is A answer comes if you get 111 gram, it contains only 142 chloride ions of these 2 chloride. It gives you 1 chloride each in sodium chloride. This contains, it is this 111 gram contain 1 mole and they are asking for 1.39 grams. 111 gram contain, if you are getting, it is the answer should be, whatever you can see, it present here, 2 times 6.02 into 10 to the power 23 chloride ions present in 111 gram. 1 gram, 2 times 6.02 times 10 to the power 23 divided by 111. Therefore, 1.39 grams. This contains how many chloride ions? When you are multiplying that, everything, but this everything present in 250 centimeter cube. And the other one present in 500 centimeter cube. And the C answer present in 250. Answer D present in 1000. So it is everything was in 250. To find the concentration, should multiply by 1000. Once you 1000 multiply, the answer becomes 0.1 mole per decimeter cube, which is not the answer given. 0.05 is the answer. So this A answer is not correct. We'll see the B answer. Only the difference here is 500. So once you simplify this with 500, it comes exactly 0.05 mole per decimeter cube. Best answer is the B. So it's the question number 13. The best answer is the B. Question number 14. Phosgene is a compound having the formula COCl2. Question number 14. It's asking about the number of this the total number of atoms in phosgene COCl2. When you see this card, COCl2, question number 14. Phosgene is COCl2. It contains 1 carbon, 1 oxygen, 2 chlorine. Altogether, 4 atoms are present. You are given the molar mass of phosgene, which is 99. If you get 99 gram of phosgene, it contains 4 times 6.02 times 10 to the power 23 atoms are present. Question is asking for 9.9 grams. You have to get for 1 gram, 4 into 6.02 times 10 to the power 23 divided by 99 atoms in 1 gram. 9.9 grams should be 4 times 6.02 10 to the power 23, divide by 99, multiply by 9.9 atoms. So if your answer comes here, based on this would be number of atoms 2.41 times 10 to the power 23. 10 to the power 23. Answer comes for 14 is D. Question number 15. Number of structural isomers. It's again regarding the organic. Question number 15. Number of structural isomers which are present in C5H12. So it is C5H12. It is an alkane. So it can be all 5 carbons should be at the stretch, or it can be 4 with 1 branching, or 3 with 2 branching. I did not complete the rest, but it gives you maximum 3 isomers. So the answer should be D for question number 15. Question number 16, you are provided a cyclic hydrocarbon. Question number 16, cyclic hydrocarbon is given to you and it gives you with this skeletal formula. You're asking to find the total number of sigma and the phi bonds in this structure. Once you get in this format, you are not seeing all the sigma bonds which are present. So you should write it down. Every carbon should be having 4 bonds. So obviously there should be 4 bonds for each carbon. So in that condition, you can see there should be hydrogen atoms clearly. 5 bonds, no choice, 2, 1 and 2. Sigma bonds comes 1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So the sigma should be 11 1, 5 should be the 2 bonds. So the best answer is the A. For 16, the answer is the A. Question number 17, you are provided 4 bottles. So each one has one hazard symbol. So in this 17, the first symbol is the W, X, Y and the Z. So the W you can see it's written this oxidizing symbol. There is this kind of a circle and start burning is oxidizing. The second symbol shows it is flammable. Flammable and the oxidizing being different because they start burning from the beginning. So this is a difference flammable. This is very clearly corrosive because it is just spilling the liquid, damages the skin and the wood. And the Z is toxic symbol is given. Your question is which two of them should not be stored together, never stored together, is that W and the X. Because the oxidizing constants always help in for combustion and the burning. So W and the X shouldn't be stored together. 17 is the best answer, is the C. I hope you understood something to today's paper discussion. And I will meet up you again with another paper discussion with the section B of this paper. And I will come together with this kind of paper discussion with all the unit 1, 2, 3 and the 4 separated with different videos. Thank you so much for watching this video. Hope you understood something. Thank you.